Hi, this is Henk Akkermans, Supply Network Dynamics Session 1, Example 5. So, in Example 4, and indeed in Example 3, we looked at different ways of improving the performance of this system. It seems frustrating and unnecessary that with such a simple inflow of work and a capacity that adjusts to the work, we seem not able to get rid of all this fluctuation, all this oscillation. Although it's okay after a year or so, shouldn't we be able to do a better job? We saw that if you, interestingly, if you make the target lead time shorter, that was example 3, I think, that actually the fluctuation increases. If on the other end you make the change delay shorter, the fluctuation decreases. All very well, but isn't there a precise optimum? Well, for that we have to, well, we don't have to, but it's interesting to make another type of graph, one that we don't use so often, but is very illustrative in this point. And I'm gonna make that an XY, a scatter plot, comparative scatter plot between capacity available and the amount of work. Now, if I turn off the sensitivity analysis here, because that will slow us down, this is what I get. So I get a gradual moving towards an optimum value of a capacity of 1000 and of work of, yeah, what is that? Is it 2000, somewhere like that? What happens if I type in capacity 1000 and work at, well, let's see what happens if I type in an initial capacity of 1000, because I'm going to end up with that capacity anyway. And you saw that I just changed the initial value of the capacity. Yet another parameter. Okay, we start at 1000, but we don't stay there. Because first, the system, first we reduce our capacity. Why? Well, we don't have enough work there to justify the 1000 capacity. The work builds up, and then, yes, then we have a little overshoot, and then we have enough capacity. Well, perhaps we should have a bit more work there. How about 2000 of work? Would that help? Again, I change the initial value of work. What happens then? Well, you may not see it, but the simulation is running. And we keep at this little point here. Nothing's happening. So apparently, if we have an initial value of a capacity equal to the what we call the steady state value here of 1000 and a capacity of 2000, of work of 2000, sorry, then we have a stable equilibrium. But if we deviate only 1 point of those, then we'll have this gradual converging process to this. An interesting behavior for an apparently so simple system, which in the end, for a mathematical person, isn't so simple at all. This is still a second order nonlinear differential equation, and those are not so easy to solve. But we just did.